Okay, I am an architect, actually, even though you read all that stuff. That's why I'm really happy to be here back at AIA. I've had a long history with AIA. I think architects, well, first of all, hello. Hello, world. Has anybody heard this phrase? Hello, world. Yeah. There we go. That's how machines talk. Do we like machines? Yeah. Got to be careful with machines, right? Machines aren't advanced. Well, there we go. Who knows what that machine is? They went rogue. So, well, actually, that's what's going on. This clicker is not plugged in. Where is that? Oh, that's here.
It's down there.
I don't have a signal. Sorry. So, my next question is going to be, let's see if this works. Hello, architects. Who's an architect in this room? A lot. Who wants to be an architect? You're studying to be. Fantastic. So, what I'm going to talk about today is, I'm going to talk about architects in the age of AI. And you might discover that you already are one in ways the profession hasn't even fully recognized. That's exciting. AI, architecture of intelligence. We're taking it back. It's about architecture, not artificial. Artificial intelligence is advancing incredibly fast, but buildings are not software. Buildings exist in the physical world where people live. So the real question is, who designs the intelligence behind buildings? Architects should. Architects should design that intelligence. We're not waiting for it to come to us, we're going to it. My name is Kimon, Onuma. I was born in Athens. I grew up in Tokyo, so I spent my life between cultures. Today I practice as an architect here in Pasadena, and my work has focused on what I call building informed environments. Over the years, that led to systems like the Onuma system, BIM Genie, ZyMap, which has AI in the name, it's ZAI or ZyMap, and BIMstorm, which are charrettes, online charrettes. We work with very large owners, like you heard. We are a small firm, intentionally. We got approached over the years to grow, and we said, no, we can do more with less. You know why? Because we use intelligence before AI came along. And we harness that intelligence. That's an opportunity for everybody here, no matter how small you are, no matter how large you are. It's exciting. I sit on many committees, as you heard, and you'll hear more about that later. But let's go back to Greece, where those patterns began, at least for Western ideas, about technology and architecture. When we talk about technology and architecture, we're talking about craft and knowledge. Technique in Greek. Technique means we touch things, we interact with the physical world. We're technologists in architectural practice. We are architects in the real world. So everything starts with Greece, of course, right? Everything starts there. Let's talk about Greek technology and architecture. They had an operating system. They communicated it over generations, and they refined it, and they connected it to the culture, to the politics, to all the discourse that the citizens of Athens had, to advanced society. This was an operating system before AI, but this is AI at its finest because it's still around us. They even had oracles and gods that hallucinated and thought about things. They made mistakes. Greeks saw patterns and captured them. They created machines that were intelligent over 2,000 years ago. That's exciting. How many of you have read this? Cover to cover? Some of us, yeah. Okay, pattern language. Fast forward 1977. Each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution. That's what we do as architects, right? Christopher Alexander. And guess what happened to this book? How many know what happened to this book? Guess who took a hold of it? The computer world. They based computer language, object language, relationships, and AI on the logic of this book, and it's still used today. It's still referenced today. You never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete. They questioned, can environments be computational? Can buildings respond to users? Can design be systematized? Can we automate architecture? That was a bad word in the past. I said that 20 years ago and I got kind of slapped around. You can't automate architecture. Well, guess what? Architecture after World War II was very much into systems thinking, like we saw with Bucky Fuller, the pattern language, on and on. And a lot of the conferences were more like science fairs, like where they were experimental. They weren't just trade shows or about the practice. Around 1977, something interesting happened. We lost ownership of the word architecture. I'm a software architect. I'm a platform architect. I'm going to design the architecture of the legal system. Everybody else is an architect, and they're using our words, but we have to get licensed. You know why we have to get licensed? Because it's public safety, because of a lot of things. It's good to be licensed to be there, right? So, I'm proposing, in 2026, we're taking that word back. We are the architects of intelligence. A living building. Innovation always begins with a few people willing to step into the arena. Later, I'll show you a building that proves this is not theory. This is happening right now. So, buildings are not simulations. We use simulations, right? We simulate, we sketch, we have ideas. We're amazing thinkers. We connect very complex ideas together. But they're not simulations. They house human life, and when systems fail, architectural intelligence protects life. That's what we do. We need to make beautiful places and everything, but we need to protect the environment, the people in it. But when systems fail through fire, war, technology, people die. So I'm going to take this down a level, because we have to have a challenge here. Grenfell Tower, 2017, fire on the 4th floor. This is not AI, this is a real picture. 15 minutes later, it engulfed the whole building. Why? Electrical failure that burned for 60 hours, 72 lives lost. Very sad. When I bring this slide up, I almost like tear up. It's like, oh my gosh. Why did this happen? It's a silent building. This is an information tragedy. It's an information tragedy that kind of points back to the industry in many ways, the way that we operate. 2 days ago, Leon von Berlo posted this. If you want to know what the future of building operations looks like, don't look at the latest prop tech startups in Silicon Valley. Look at the Pentagon. And I'm not getting political here. This is happening right now, right? A city's being destroyed, a country's being destroyed with technologies that could be reversed. If they can use these technologies with satellite imagery and hacking the cameras on the streets to understand the environment, building a digital twin in real time of a city to attack it. Now flip that around and imagine if that same vision and the capability was flipped around into design and construction for the better of humanity, right? The technology is the same. It was Palantir and Claude and all the tools that we're using are being weaponized, which is not a good thing. But we can use the same capability. We're playing with fire, but fire is very good in certain instances, as long as we know how to manage it. But AI makes mistakes. But this was not an AI mistake. This was a mistake of not knowing what that building was. This is still coming out in the news. Why did the school get attacked? Because they didn't know it was a school. That's the excuse. I didn't know it was a school, but it was some kind of a military facility. So this is an intelligence failure, not an AI failure, even though AI was used to attack it. So intelligence. I presented this at Greenville last year. I said the most sustainable resource is intelligence itself. Yes, all the materials and the LEED ratings and everything are about sustainability, but our intelligence of how we put the buildings together is the sustainable material that needs to be protected and grown and shared. Just like we're seeing today, we're sharing intelligence here. So rewind 1994, we started using BIM in the early 90s. We were told we couldn't do projects this big with BIM at the time. It was just not capable, but we did it. We built our own applications, smart objects and buildings, and we put intelligence into the objects that interacted with the planning, so we can do rapid planning for government facilities. This was Yokosuka Navy Base, a lot of other facilities there. We embedded the rules and logic in the objects. You guys are doing that already today with your BIM tools. You are doing that. We had started that back then. In 2003, we won the AIA Pasadena Foothill Award for the Object Genome Project, where we said objects can have the genetic code embedded in them, so we can automate design, so we can spend more time on the stuff that we cannot automate. The creative part, crunching numbers, looking up information, that's not value add. The value add we have is the complexity and knowledge that we have as architects. And then we built our own application that you can actually, I'm not going to talk about my tools very much today, but you can see them online. But these are on cloud-based tools that we built in 2000 that were used for designing Homeland Security headquarters in Washington, D.C., things like that. They brought us in and said, how can a small team like you guys do these complex projects? Because we use automation, because we use intelligence, because we don't waste resources. And 20 years ago, I wrote this for the AI, the Report on Integrated Practice, 21st Century Practitioner. Most of what's in there is still relevant today. It's about AI, it's about smart systems, it's about data, it's about BIM, it's about GIS and location. I'll send this to you. I'm not sure if it's even out there anymore, if you want it. All of this material, by the way, at the end I'll show you how you can get everything and more. We started BIM storms, which are modeled after charrettes. And charrettes are fantastic because we get people in a room and we can interact with humans, right? We put stuff on the wall. We said, what if we turn that into an online collaboration? And we've had hundreds of, these still are free events. The reason they're free is because we learn from others. What kind of tools do you have that we can do in a charrette? Oh, who else is there? Our competitors there. Bring the competitors in because we learn and they learn. And oh, by the way, sometimes owners come to us and say, can you do this for the State Department, for all our embassies worldwide, and teach our architects how to work with intelligent data? Sure, it turns into another value chain that we can have for owners because our intelligence is valuable in other ways other than just designing the project. California Community Colleges, largest community college district in the US, maybe the world, is using our system. This is for 15 years now. It's BIM, GIS, in the cloud, 5,000 buildings, 6,000 assets in one school district, and it's growing and growing and growing because it's easy to use. We designed it like an Uber app. If you can call up an Uber, you should be able to call up your building. Get me from point A to B. How much is that going to cost? Here's my credit card. AIA Japan, 2023. When ChatGPT first came out, we said, wow, we can use this for automating design. And we told AIA in Japan, let's call it AIA, Architectural Intelligence for the AIA. So this started in 2023. Okay, so how many go to the AIA annual conference? Don't? Why not? Many have been more. Okay, how about Greenville? Okay, if you design intelligence, a smaller conference, a lot of interesting conferences here. AHR, as we go down here, how many of you have heard of Scale or Neural PS? Scale just happened in Pasadena. It's the largest open source AI conference in the US. Neural PS is a case study. I went to these conferences, every single one of them. I presented at most of them. I cataloged it, I wrote articles so you can read the details. You don't have to go to all of it. It takes a lot of time. It's really exciting to go, and I learned from it. The reason I'm so intent on this message is that we've identified with other experts in the field that AI is advancing at 10 times a year. It's no longer the old computational scale, 1.5 times every 3 years. 10 times a year, that's the pace right now, which means in 2 years it's going to be 100 times more powerful than what you saw today. Do you believe this? I'm not sure if I believe it, but that's what they're saying, 1,000 times in 3 years. What's going to happen with this? Imagine how much energy this is going to need. It's not scalable. The data center concentration, the amount of energy that's needed, it's going to wipe us out. It's already eaten up the budget for construction. We've seen those charts where data centers there's more being spent on data centers. So I went to these AI conferences. So has anybody actually gone to these conferences? Because it'd be interesting to kind of trade. Yeah, it'd be great to talk about them because I found it very instructive. So last week at Scale 23, Cindy Cohen was wearing a t-shirt that said, "Let's sue the government." I go, "What are you talking about?" And she was a keynote speaker. Here's her story. In the 1990s, the US government literally classified encryption software and code as military munition. In other words, if you shared a line of code that could encrypt something and you sent it through email, you could be arrested, which a lot of PhD students were threatened with. She said, "This is ridiculous. This is free speech. I'm going to," in the 1990s, she won the case. She went all the way to DC and she won it. She won it, and it changed everything about what we do with the internet today. If she didn't do this, we would not have been able to encrypt our banking transactions or have secure communication or the internet for that matter. So she was brave enough to do this and change the world, and now code is free speech. Code is free speech. She has a book out. Okay, this conference took my breath away. I was at the AHR conference. ASHRAE, has anybody gone to that? That's a monster conference with all the mechanical systems, all the stuff that uses energy that we want to save energy on, right? Air handling, they're all there. It's massive. I went there and I met Judah Goldfeder from Google. He's in this picture here. He's also from Columbia University. He invited me to come to Neural PS in San Diego. I said, "What is that?" It's a neural processing system. San Diego, the largest AI conference in the world that is doubling in size every year, with people from around the world just clamoring to get in. 8,000 poster sessions. Imagine San Diego. You walk in, there's 8,000 poster sessions like that. Every one of them are PhD students or researchers or academics. They're not only presenting their ideas, it's like presenting your thesis and getting hired on the spot and getting funding to do your next $1 million project. They're doing it in real time. And as you walk by these sessions, like that, Google and whatever, people are grabbing you and say, "Hey, are you in this world? We want to work with you." This is the world that's happening right now. Now, what took my breath away and shocked me, I was invited there to talk about urban AI and AI and smart buildings. So I did that. I stood up. There was 100 other posters in the room. It was a full-day session. And as I was listening to the other presenters, guess what they were doing? They were training large language models how to optimize building operations and energy, how to automate design, how to automate city planning. And they were using what's called synthetic data. You know what that is? Fake data. Do you know why they're using fake data? Because they don't have the real data. They don't have the real data of the buildings that we're designing with BIM. What's going on here? If BIM has all this data, and we're holding it so close, and they're faking the data, we're going to get more hallucinations and problems. That is a problem. But it's an opportunity for every single one of us to think in terms of how do we share our IP and still protect it? How do we share our knowledge and intelligence and grow? And I'm going to show you how to do that. Another insight from those conferences. it's interesting because these technologies, these guys that are building AI, they're having sessions about ethics and politics and human behavior and sense of place. It sounds like an architectural convention from the 70s maybe, or 60s. Because they need to understand how to control and train AI. So if you're not in the arena, if architects don't participate, in other words, others will. It is not the critic who counts. The credit belongs to the one that's in the arena, Theodore Roosevelt. In other words, if you don't try and fail, you're not going to succeed. You can sit on the sidelines and wait for things to happen, but then it'll be too late. We need to be in the arena. This is the arena, back to Greece. They had a race, the Olympics. It was called a stadion. A stadion was 600 steps, about 630 feet. If you're not in the arena, and you go in naked at the time, actually, to race, with your enemies in place. So, Prometheus brought fire to humanity. Architects have always been the ones who transform fire into civilization. And I'll play a short video here.
The cheese has moved. Remember the black box bones? We were trapped. Trapped in a closed system, to wires. Trapped to death. Trapped to payphones. Then freedom. Connecting anywhere, anytime. Open source is everywhere, driven by Linux. Yet buildings are black boxes, automated but not smart. The owner's data is trapped. Until now. The black box is gone. Open with the interoperable building blocks. Connection profiles. BIM and digital twins. Get it. Use it.
You'll notice the date, this is 2025. You'll notice that this was AI generated last year. We had the vision, but I'm going to show you the reality of what happened next. And this is not one product, by the way. I'm not talking about one product. I'm talking about a coalition of products. The way the internet was built was through Linux. 80% of the servers out there are running Linux. All of our devices are dependent on it because it's open source, just like Cindy talked about with that open thing. If we have proprietary tools, we're going to get trapped in that proprietary AI, LLM, or BIM application or digital twins. It's about connectivity. Connectivity happens through open connections, and that's what the Coalition for Smarter Buildings is doing. It's a large coalition of national labs, vendors, software vendors, architects, engineers, and I invite you to be part of that. It's free to join the coalition. I'll tell you how later. The coalition is part of the Linux Foundation. The Linux Foundation is massive. They have every other vertical in there, finances, agentic AI, all building their own solutions that you can use as an open solution, many of them free, which means you don't have to start from scratch. This is the answer earlier, how do small companies get involved with this? This is how you get involved. You don't start by buying every single application out there. You think in terms of how do you build an ecosystem, an open ecosystem, and you can compete as an individual, especially with AI now. There's some crazy talk about a single person making $1 billion company. As an architect, with AI, you can do a lot more, as you saw, and it's going to just keep growing. The Coalition for Smarter Buildings just joined the Linux Foundation about 1.5 years ago. They fit into that vertical industry. See these horizontals there? All of this stuff interconnects. And this is their website. I'll point you to it. They put me on their cover, actually. I said, I've never seen a convergence like this. And what I'm talking about is a convergence from last year to this year, 1 year time span. This is a story here. So, the PA live-in building. This is what architectural intelligence actually looks like in a real building. It's in Portland, completed in 2021. ZGF and PAE engineers, 58,000 square feet, net zero energy, net zero water, 20 EUI. Solar panels on the roof, they're producing more energy than they can use, they're pushing it back out to the grid. The basement is the size of an Olympic swimming pool that collects all the water. The first floor has these big blue tanks, which you'll see later, which takes all of the waste of the building and doesn't put it out to the sewer. They sell it as fertilizer in the end. This building itself is beautifully designed. It's an amazing building, timber structure. I won't get into the architecture, you can see it online. Behind this elegant architecture is an extremely complex system. It's built to last hundreds of years. Another wonderful place inside. They live and work in this. They work in their own building. These are PA engineers working in their own building that they engineered with amazing systems in the building. These are the blue tanks for the waste. Oh no, actually that's the utility. Every system's reporting data. They all have dashboards reporting what they're doing. They have batteries in the basement with PVs, and they had BIM. What did they do with the BIM? They flattened it into PDFs, into digital files, and then put it into the basement. These documents. How many of you have seen this? All of that amazing effort. These are the engineers that designed their own building to be a living building that's higher than LEED, whatever. They can't get to their own data because they trap themselves by over-controlling the data, that the systems that they put in did not let them get to it. And oh, by the way, there's a lot of AI tools out there that can take these documents and scan them and get data out of them like we saw, which is really important for old documents. But a really bad idea for BIM that turned into a document that got scanned, that using all this energy and these centralized servers that's killing all the data in the world and energy in the world. So that's why intelligence is a sustainable material. Okay, so relationships, as we know, when you get engineering documents and architecture, there's all these relationships. Where's the outlet for that thing? Which switch? How does this energy? All that stuff is gone, right? So what we did with them, with the Linux Foundation Coalition for Smarter Buildings, we're using technologies that are open to say, let's connect the dots. Essentially, it's a wiring diagram, but in machine-readable format, which means AI can connect it to that, so it doesn't hallucinate on PDFs of line diagrams. It looks at the absolute information. This is what it looked like in Revit, amazing Revit model, very little data. And here's the other amazing thing. I've never seen an engineer and architect willing to share their mistakes so openly to the point that they're posting their files on GitHub with what they did so others can learn and they can learn and move themselves forward. In other words, they're collaborating with the industry. They're not weaponizing this and saying, we're going to do this for ourselves. We help them take these documents, turn it into data, take the Excel files, create the knowledge graph, the wiring diagram, so AI can talk to that in the BIM model. So it's basically a cloud, what we call a cloud BIM, which you'll see here. Let's see if this is going to play. There we go. This is their model. Actually, this is our app. This is the Onuma system, but I'm not pushing that today. It's basically, and there's live data now coming in from 10 different systems that they couldn't see side by side, that we help them get around the data so we can see the energy use day by day, minute by minute. Then when you go into the building, there we go. Inside the building, you can get down to individual rooms, sensors in the rooms, occupancy sensors, CO2 sensors. So it's the heartbeat of the building that the engineers that won this award were not seeing their own data that they engineered because they put it in the wrong format, and then they realized, well, that's a bad idea. Let's not do that again. So it's an opportunity to learn and do this in a better way. Okay, I'm kind of rushing to, I'm almost there. Good, okay. So this is the conclusion. We started with technology. Here is how we get to architectural intelligence. It's crafting. There's nothing new about this story. AI just got layered on top of it, but there's nothing new about this story. It's how do we capture knowledge and information the way that Greeks did, the way that pattern language did, the way that Bucky talked about. It's all there. We are the architects that know how to put this together. And it's very complicated when you put it all together, but because we talk the same language, we can do this. We can absolutely do this. But we have to get into the arena. Logos, logic, structure of knowledge. When you have a mechanical system or electrical system, and it ends up in a roll of documents or a PDF that nobody can read when something happens, then fires like Grenfell happen. Mistakes happen. People can die. But if you take it and you take just the pieces that you need, and you don't need a detailed 3D model to do this. That's the other myth in the industry. LOD 1000 or 500 or 600, if you have a very detailed model, we can do everything. No, you can barely keep it alive in Revit during design. How are we going to keep it into operations? You keep it lightweight. You get the graph model, it's called a knowledge graph out of there. It's the same data. It's just not put into spreadsheets, it's put into relationships. And the relationships have meanings. In other words, it's not just I'm a light. It's I'm a light that needs energy, that puts out this many lumens. Each object is telling a story that can stand by itself, that can be connected to other systems. And when you do this, you don't need one application to do it all. Everybody's using the same format. You don't even need the same standard. You just need the same structure, the knowledge graph to connect to each other. Nous, understanding intelligence, insight. Get insight by having this reasoning captured in the building that can be used by humans and AI. There's no difference. One thing I didn't say about this AI conference. It was terrifying and it was exciting at the same time. The guy that coined the phrase AGI was there, and I talked to him, Artificial General Intelligence, and he said, it's probably 2 years out. The industry's saying 5, but it might be 2. It might even be faster, but nobody knows. They're saying we have to get in front of this. And the way we get in front of it is we collaborate and we open up our systems and talk to each other. So here's the stack. At the very top is human intelligence, then it's AI and machine learning, semantics, the meaning of things, that you get those knowledge graphs. We somehow have to have a common language, otherwise I'm talking Greek and you're talking Japanese and we don't understand each other, right? The data, the sensors, the telemetry. If we're going to be talking about sustainability and energy, if our buildings don't have a heartbeat, we just have dead data, dead buildings. And the physical world that we represent the physical world better than anybody else. We touch things, we know how things work. We go up to the wall and we touch to see what the material is, right? That's what we do. And architects are between these two worlds. Many of you in the room are called maybe BIM managers, digital leaders, technology specialists, but that's not really what you are. You are architects of intelligence. The profession just hasn't caught up yet. The future of architecture will be designed not only by architects of buildings, not only software architects, but architects of intelligence. Every single one of you is an architect of intelligence. Let me get the term right. As architect, you need to be licensed, but architect of intelligence, anybody's an architect of intelligence, especially if you're here today. So I'm going to invite you to join the Coalition for Smarter Buildings. It's free to join. It's part of the Linux Foundation, which is massive. In my working group, it's called Cloud BIM. The Cloud BIM project is what PAE is. And in that project, we're posting stuff on repos. We're having weekly meetings. We're collaborating. We're finding the problems. And we're moving fast. And the way that you're going to move fast is you don't have to start from zero. That's the goal here. We don't all want to be islands. Okay, in closing, you have to enter the arena. The instinct after a conference like this is to go back to the office, build a new tool, a new platform, a new proprietary advantage. But if we do that, we will simply recreate the same silos that held our industry back for decades. The opportunity in this moment is different. We now have the ability to build, connect, and share systems in ways that were impossible before. So if this resonates with you, post your thought, question, or even a repository you're working on. Let's start connecting these efforts into this ecosystem I talked about. Technology should not be used to weaponize knowledge inside firms. I'm going to say that again. Technology should not be used to weaponize knowledge inside firms. That's destructive. You need to figure out how you can share your IP and protect your IP and make tons of money doing it, because it's possible. Architecture has always been about civilization. Now it must also be about intelligence. So if you post, this is my LinkedIn, the way you get all this, I'm recording this, and I have a ton of other material, and I have a ton of other roadmaps and strategies and places I can point you to. Tell me what you want to do, how you're going to collaborate. You can come in and look too, but I want to find the doers here. Who's ready to do something? If you're ready, we're ready. We can change this industry. We can change the world. I'll be at Greenbuild with PAE. We'll be presenting there. So join us there as well. There's other presentations. And I'm involved with a lot of other organizations. I won't go through them all. You'll see them online. In fact, Melvin did a great job of kind of introducing them all to you guys. Okay, so that's it.
Okay, we have some time to take some questions. Anyone have any questions? We have one right here.
Yeah, thanks for the mind-blowing presentation. It's really fabulous. You're saying about like we should like on our kind of IP to go like against, because I'm thinking about how the tech kind of industry grows so fast is because they share their knowledge on GitHub, whatever. So that's how they kind of grow that fast. But in the contrary, now the AI is getting in, and it's so easy for the AI to get those tasks, like whatever code is up there, and so they are the first row of getting replaced. But the other thing that the AI hasn't been able to replace the architect role is what you're saying, the physical role. That's the part that AI, if we don't have a sensor that tells what is really going on in the physical world, that AI have no idea what they can do. So I'm thinking about, now we have the sensor and the smart building to give the data and measure the building system things, but have there any conversation about how we document humans' feeling and thoughts? Because ultimately, it's about how people feel and use the space.
Yeah, great question. There's several in there, actually. So one, first of all, the sensors are an important piece, but it's not everything. It's that building in Tehran that was a girls' school that just says, I'm a girls' school versus a command center, which I've seen over and over again with GSA, with Homeland Security, with all these government agencies can't even point to the building and say, this is a building in many cases. So that's one. The IP part, if you don't put all of your IP in one bucket, i.e. Revit, or i.e. Big Data Lake, or i.e. whatever, then you could segment it and say, who are you and what do you want to do with this piece of data? Do we have a contract? Yes, I'll send my agent to you. But I can still protect what I want to protect. In fact, that's how you protect IP, through because if you're using open source connections, then you know the data that's flowing back and forth. So I know what's going out to whatever tool it is if I have that open connection. If it's not open and it's whatever, ChatGPT or whatever, we don't know what they're doing with that, right? So in fact, at that conference, there was a whole day session about open source AI that you can build on your server or with a network of people that have their own servers. We don't have to rely on a central system to do that. And the other terrifying thing that I heard at the same conference was when we're centralizing servers for large language models, guess who's pushing that idea? Meta, Google, all the big boys. Why are they doing that? It makes money, right? It's natural, that's what they do. But you centralize a server farm, you put billions of dollars into it, guess what it becomes? A target. What happens when it becomes a target? Our whole infrastructure can go down, whatever, like this war that's going on. So there are ways, it's not one or the other. What you need in those scenarios to understand how to protect things is the architectural knowledge that we talked about, intelligence, because we know the relationships. So that it's not just the sensors, it's the physical building, it's a sensor, it's the people in the building and how we interact with it. In fact, at the AI conference, there was a lot of researchers just looking at behavior of people, psychology, all that stuff was there. Everything was there, it's amazing. So that's why I'm saying that if we don't have to reinvent the wheel, we can use that knowledge, the research that's happening, and apply it to architecture. And then we just show how that's valuable. Sorry, that's kind of a long minute. Did I answer everything? You had a lot of questions there, but.
Yeah, that's, like, yes to the open source, but I'm still thinking about like, is there an past example of how you document people stealing
How you document people's
or
feelings.
experience?
When I get into an Uber and I don't like the ride, I put a star on it. That's my feeling.
But would like a day-to-day user in a building need to keep documenting, commenting of how they feel or how they complain? Because sometimes I've had a bad experience in a restaurant, but I won't do any comments because that's gonna take my time.
Absolutely, yeah. And in fact, PA's doing that. They're tracking people's walking up and down the steps so they can encourage you. Hey, you took these many steps, and here are the steps, and the steps light up. And we said, you can use those same sensors for emergency evacuation, not just for exercise. So yeah, there are many ways now that we're essentially connected to our feelings and our health and everything, there's going to be so much more possible there. But that's an important piece because as architects, we understand how people function in the building, which means that's another skill that we can connect.
Kimon, we have a question over there by the back monitor.
Thank you so much, that was great. I was just wondering how can you, if you can explain.
Speak up a little bit. I can't.
Can you hear me? Okay. Can you expand a little bit on how you have been able to successfully collaborate with the public sector as we often see the bottleneck with projects with often lies with here at the, especially local government's ability to process, oftentimes the bottleneck with the local government staffing, expertise, technology use. So how can we help the public sector move and adopt some of these technologies for to build better?
Great question. So the problem that we have as architects is we wait for that scope of work to come our way, for the owner to have that vision to say we want to build this building, and then we say, yes, we'll design it for you. We need to move upstream. There are many ways of moving upstream, especially if you can tell these stories. I'll tell you one way that I did it. We worked with the Coast Guard close to 20 years ago, so we wanted a BIM of all of our buildings. So we started building BIMs of all their existing buildings. They said, what can we do with this now? And I said, well, if you're in Seattle and you're on Alaskan Highway, and there's a truck going here on Alaskan Highway and it blows up, it's going to take this building down. That building was their command center. I didn't know that. We set up a story to say, well, here's what you can do. And then 2 weeks later, they put an RFP out for 65 new command centers. And they hired us to help them write the scope of work. So you have to get ahead of waiting for the owner to come to you. And you guys are connected to owners, but we're not telling the story to owners enough because we're too passive and waiting for that contract. Others are stepping in and going to take over that. And I think that's what we should be doing. That's my strong belief over the years that what we have done.
Come on, I have a question in the back here.
Hi, thank you so much. A couple of questions here. I'm just trying to wrap my head around the exponential nature of this, that 1000x multiplier. Maybe you could just expand on that about the next couple of years. If that really comes to fruition, it seems like intelligence will pass human intelligence, and how do we reconcile that? I also am curious about all of the systems that you displayed in your living building. It seems like this is becoming more and more of an energy game. The lead in sustainable design movement really has been an energy game, an architecture game. So maybe you could speak about the relationship of how architects can be the conduit or managers of all of the engineering systems that are required to pull all of this off, even though is that something that architects are going to have to become engineers moving forward, or thank you so much.
Yeah, great question. So the engineering side, it's not just for engineering. It just so happened that these engineers were willing to share their models. The architects, unfortunately, in this project did not jump in yet. We're trying to get more in there, which is why I'm here, actually, not just for the PAE building. But definitely, it's not just about engineering. Because as we know, when you look at life cycle costs and LCA, all the other types of sustainability scoring that happens, it's not just about energy, but yes, it is a big part of it. It's a big part of it because it's the biggest cost for an owner. That's why these AHR ASHRAE conferences are huge. So yeah, I think we have to step into that story and figure out how our design, whether it's the human factor, whatever it is, there's so many touch points and we can't solve it all. That's another message that I want to make clear. You don't have to do everything. Because if you try to do everything, you get overwhelmed. You just have to know what is my specialty and how do I plug in. Because if you, today, for example, if you were not on the internet and you couldn't use email, I wouldn't be able to communicate with you except by sending that letter, right? It's still possible. But the first thing is connectivity. Don't get stuck, like was said earlier. Don't get stuck in any application. Don't get these long contracts. Just admit, applications are becoming disposable. People are building their own apps, especially if there's a platform that you can plug on top of. You don't have to build the whole stack. You can say, I have an idea for an Uber app. That's how Uber happened. They didn't fly satellites. They said, we have an Uber app. So there's so many opportunities if we start learning from this software architects that took our title away and bring it back into here and bring it for architecture for ourselves to use. It's just amazing. As far as the AGI, even the researchers there were terrified. The guy that invented the word AGI said, yeah, this is a problem. It's coming fast, 10 times. We don't know how it's going to scale, but it's coming. The reason the Scale Conference was interesting, it's an open source convention which brought Linux to the world. If Linux wasn't around, and if that, I forgot her name now, Cindy, didn't open that lawsuit up, we would be stuck in Microsoft world or Apple world or whatever, Google world. Well, that's where we are right now. We're all moving like flies, like moths toward the light of these large AI companies. And that is okay, they're valuable, but we need a balance. The way we balance it is we demand open source applications as well. We build our own applications. We say we are not dependent on anybody. And as a small company, that's why I was asking these questions. I have an agent that wants to connect to your agent. I don't know what you're doing, but I have something that's valuable to you. Let's do something here. And it's like that. If the technology's lined up, the agents start talking, and we have a whole new value chain that can change things. You can imagine all kinds of things. Anyway, I'm very optimistic, but I'm terrified.
We have time for one more question.
I have a quick question about our business model as architects. Because of course, if we're paid for the time it takes to do something, so what happens now to our project deadlines, right? Which the idea of them being delivered faster seems impossible, and we pay less as well. So what happens when these tasks get automated, and it's not weeks or days, it's minutes to do something?
Yeah, it's a great question. It's the hourly rate question, which I'm not going to talk about in details. We're not supposed to, right? But in general, what I did, and this happened 20 years ago, the Yokosuka Navy base that I showed you, when we started using those tools, we did it so fast. This was 1993, 94, with BIM on a huge Navy base that we had to basically shelve the deliverable for a few months to let it kind of cook and interact. I'm saying that now, I couldn't say it back then. That's why we stayed as a small team. It's the value that we deliver. It's not how many hours we spend. It's not how many hours and meetings we go to. It's not how many, I was negotiating with Corps of Engineers years ago, and they said, how many square feet of, 65 sheets. Can you reduce it to half sizes? I could do it on a postage stamp if you'd like. We could reduce it to nothing. So it's that ridiculousness that we have to get over, but we have to tell that story and that dialogue because we know it. And yeah, it's going to be a challenge. It's not a technology shift, it's a cultural shift. But we're really good at cultural shifts, I think. We know how to interact at that level. Thank you very much for your questions.
Come on, thank you very much. That was fantastic.